Hello everyone. So in this video we are going to see the topics from the subject of engineering mechanics. Basically engineering mechanics is the branch of science which deals with the study of bodies under the state of rest or motion when in action of forces. So our first unit is about the statics of particles, and then we learn about equilibrium of rigid bodies, and then properties of surfaces and solids, and dynamics of particles, and finally we will see about friction. So these are all the topics we are going to cover in this video. So let's get started. Our first topic is about the statics of particles, in which we will see some of the basics from engineering mechanics, such as introduction to engineering mechanics, and then units and dimensions, and different laws of mechanics, and about Lami's theorem, and parallelogram law and triangle law of forces, and about the principle of transmissibility of forces, and basic vector operations such as vector addition, subtraction, multiplication. So in multiplication about dot product and cross product, and matrix, unit vectors. So these are all the things we will see in vector operations, and we will see the equilibrium of a particle in space. So this is about 3D, 3-dimension means we will see about x-axis, y-axis and z-axis. So and finally we will see about single equivalent force. So these are all the topics we are going to see in the statics of particles. So in case of introduction, we will see about the engineering mechanics. So already I said the definition for engineering mechanics. So study of forces that act on bodies and the resultant motion that those bodies experience. And engineering mechanics is the application of mechanics to solve engineering problems such as robotics, aircrafts and spacecrafts. So these are all the few applications of engineering mechanics. So initially engineering mechanics is developed from Newton's law. So Newton developed architect mechanics, so under the state of rest and motion of bodies, and different laws of motion and law of gravitation. So we might have studied in schools itself about the Newton's first law, second law and third law. So these are all the things developed by Newton, and it is known as classical or Newtonian mechanics. And scientist Einstein developed a speed of light. So this one is called as the relativistic mechanics. And other scientists Schrödinger and Broglie, so they developed atomic distances concerned in study of particles. So that one is called as the quantum mechanics. So these are all the development of mechanics, and the branches of engineering mechanics. So engineering mechanics is classified into two divisions. First one is mechanics of solids, also called as solid mechanics, and other one is mechanics of fluids or fluid mechanics. So mechanics of solids is divided into two types. First one is mechanics of rigid bodies. So rigid body means the body which does not undergo any deformation during the application of forces. So this one is called as rigid bodies, and deformable bodies are the ones which undergoes deformation during the application of forces. And rigid bodies is divided into two types. First one is statics and the second one is dynamics. And in case of dynamics, it is divided into two types, that one is kinematics and kinetics. So initially statics means study of the bodies in the state of rest condition, and dynamics means study of the bodies under the motion. And mechanics of deformable bodies, it is classified into two types. First one is theory of elasticity, and the other one is theory of plasticity. So elastic condition means it regains its original shape after the application of pulling force, like that. And theory of plasticity means this does theory of plasticity means the body undergoes deformation and it does not regain its original shape after the removal of forces. So that one is called as a plastic condition. Next one is mechanics of fluids. So it is also called as fluid mechanics. It is divided into three types. We will not be considering these topics in our engineering mechanics, but let's see the three different types. First one is ideal fluid, and the second one is viscous fluid, and third one is incompressible fluid. So initially engineering mechanics is from the topic of mechanics of rigid bodies. So in case of deformable bodies, we will be studying in the subject called as strength of materials, but rigid bodies comes under the engineering mechanics. So in statics, we will see about equilibrium analysis of particles and bodies. So these topics comes under the unit number 1 and 2. Next one is dynamics. It is the accelerated motion of particles and bodies. So dynamics is divided into two types. First one is kinematics and second one is kinetics. So these things we will be seeing in the fourth unit. And other topics are mechanics of materials and theory of vibration. So in our subject we will be studying only statics and dynamics. So basic introduction, let's see. So basically I said there are two principles, that one statics and dynamics. So statics is the study of forces on objects or bodies which are under rest or moving at a constant velocity. So basically it may be in rest condition or in the constant velocity motion, and the forces are in balance. So balance means it is in the condition of static equilibrium. So this one is about the statics. So example is given, a ball at rest may have several forces acting on it, such as, so there are many forces acting on a ball which is in the rest condition. So first one is about gravitational force or self weight. So self weight of the body acts towards the center of the earth, and a force opposing that gravity. So opposing that gravity means it is the reaction force. So the ball is at state of rest or static as force in balance or equilibrium. So the weight of the body acts as a gravitational force, and opposing that gravity acts as a reaction force. So the action and reaction force gets into the condition of balance or equilibrium condition. Next one is dynamics. So dynamics is the study of forces on moving bodies and the forces that are in dynamic equilibrium. So we will be considering the forces of the body under the condition of motion. So that one is called as a dynamics, and we will be studying in equilibrium condition. So in this slide we can see there are two images. So when we are using in a system, we can click on these images and we can see the animations such as ball in rest condition and ball in motion. So these things can explain about statics and dynamic conditions of a ball. So the concept of applied mechanics usually when it comes to analyzing stress, designing of machine structures and hydraulics. So in this also there are two images in which we can click and see the beam under the stress, and also hydraulics. So these things I will explain in the last by opening these images. And second one is we will see about the basic units and dimensions used in engineering mechanics. So there are only 7 basic units in SI units. So only 3 are frequently used. So frequently used means we will be mostly using for our calculation purposes. So physical quantities that are mostly used are, first one is length, second one is mass, and the third one is time. So the unit for length is meter. So length we will calculate about distance. So that is mentioned as meter. So the symbol for meter is small m. Next one is mass. So mass is denoted as kilogram. So we will mention it as kg. And third one is time. So it is mentioned as seconds. So in a symbol we will mention it as s. So for large or small figures, so large or small figures means we will be seeing from kilogram to grams. Multiples or submultiples are used. For example, so first one is 1 kilogram. It is said as 1 kg or 10 power 3 grams. So this one is called as a multiples, and submultiples are 1 millimeter is 1 mm or 10 power minus 3 meter. So in case of multiples, kilogram is converted into 10 power 3 grams. In case of submultiples, millimeter is converted into 10 power minus 3 meters. So similarly for other things, 1 megagram, so it is converted from 1 mg or 10 power 6 grams. 1 micrometer is 1 micrometer or 10 power minus 6 meter. 1 gigagram, so it is mentioned as 1 capital G small g or 10 power 9 g. So in case of nanometers, 1 nanometer, it is mentioned as 10 power minus 9 meter. So some of the SI units that are frequently used are force. So force is normally denoted as Newton. So in symbol we will mention it as capital N. So 1 Newton is the force applied to a 1 kilogram mass to give it an acceleration of 1 meter per second square. So that is 1 Newton is equal to 1 kg into mass divided by second square. 1 kilogram meter per second square. So that is about 1 Newton, or force is equal to mass into acceleration. So the unit for mass is kilogram and the unit for acceleration is meter per second square. So 1 Newton is equal to 1 kilogram meter per second square. And also 1 kilogram mass has a force of weight due to gravity. So gravitational acceleration due to gravity is 9.81 meter per second square. So we can convert it into Newton by multiplying 1 kilogram into 9.81 meter per second square, which is equal to 9.81 Newton. So when we are denoting the unit as Newton, it is called as weight or force, and when we are denoting the force mass of the object as kilogram. Okay, so converting from kilogram to Newton, we are using 9.81 meter per second square as the acceleration due to gravity. So next one is moment. So moment is the product of force and its perpendicular distance, and the unit is Newton meter or symbolic form Nm. So these are all the basic things we are going to use frequently while solving the problems. So basic concepts, let's see about space. So space is the collection of points whose relative positions can be described using a coordinate system. So coordinate system means we can mention as x, y and z. So three directions are used in graphs. Normally we can see x axis, y axis and z axis, and also we will see the positive side and also negative side. So by using this we can mention the position of an particle in the graphical way. So this one is called as a coordinate system. So time, so for relative occurrence of events. So when many events are occurring, we can mention the relative of time related to starting point and ending point and the difference between those duration. So position is normally we can mention the points as its position, velocity and acceleration. So position means normal starting point, and in case of velocity we will see about meters per second. So distance travelled by time taken, and acceleration is meter per second square. Next one is mass. So mass is the resistance to change in velocity. So change in velocity means, so it is explained in dynamics. So basically we will see mass of the object in any planets. So it is mentioned as kilogram, but in case of dynamics this definition is used. And quantities that influence mutual attraction between the bodies. So that one is explained in statics. Next one is the particle. So particle means about the rigid bodies. So rigid body we will consider about the body which does not undergo any deformation, and a particle is the one which has negligible dimensions. So negligible dimension means we can use one small dot. So small dot doesn't have any dimensions along the x-axis, y-axis and z-axis. It is normally a dot. So it is denoted as a particle. So next one is the rigid body. So already I said it is about the negligible deformations, a body which does not undergo any deformation. Next one is non-rigid body. So a body which can undergo deformation. So when you are applying a force on a body, it goes under deformation. That one is called as change in dimensions of the object. So first one is a body. We can see an image, smiley image, and second one when you are applying a force, so it does not undergo any deformation. That one is called as a rigid body. And third drawing is when you are applying the force, the body undergoes deformation. So this one is called as a non-rigid body. So second diagram is rigid body, third diagram is rigid body, non-rigid body. So one point is that before considering whether the body can be assumed rigid body or not, you need to estimate the relevant force first. So relevant force acting on the body need to be estimated before considering the rigid body or not. So in statics, bodies are considered rigid unless stated otherwise. So unless a body is stated as rigid body, we will consider as rigid body. So force. So force is the vector quantity that describes an action of one body on another. So action of one body on another means when you are applying a force on the another body, it is called as a force. And it is a vector quantity. So there are two quantities normally, scalar quantity and vector quantity. So when we are considering both magnitude and direction, it is called as a vector quantity. When we are considering only the magnitude, it is called as a scalar quantity. So first definition is about the static condition, and second one is, in dynamics, force is an action that tends to cause acceleration of an object. So the SI unit of force is Newton. So already we have seen the unit for weight and force. So both are only Newton, and 1 Newton is equivalent to the 1 kilogram meter per second square. So already as we have seen in the previous slide itself. So 1 Newton also can be denoted as kilogram meter per second square. So as I said, difference between scalars and vectors. So scalars are associated with magnitude alone. So example for scalar quantities are mass, density, volume, time, energy, etc. So these are all the things which will be having only magnitude. So for example, in case of mass, so it is having only kilogram, mentioned unit is kilogram. So we are not considering the direction in which the mass acts. But in case of vectors, it is associated with both magnitude and direction. So in this we will see the example as force. So already said force as the unit of Newton. So the Newton is derived from force is equal to mass into acceleration. So in case of mass, we are having only the kilogram as unit, and it is only the magnitude. And in case of acceleration, it has, we can consider that the weight of the body acts towards the center of the earth. So it is called as a acceleration due to gravity, small g. So the unit is meter per second square. So meter per second square means it is acting towards the center of the earth. So it is the direction of the force. So this one is called as a vector quantity. Similarly for other things, when we are considering displacement of an object, so we will mention the starting point and the end point, and in which direction the object moves. So that one is called as a vector quantity. So we are considering both magnitude and directions. So normally vector quantity is mentioned as in direction arrow mark. So V, like that we will mention as vector quantity, V vector. So when you are finding the magnitude of an vector quantity, we will take modulus of V vector or V. Next one is the direction. So direction is mostly mentioned as theta. So theta is called as the direction of an body in which it acts. So there are different types of forces. Normally a concurrent force. So concurrent force means it acts on a single point. That one is called as a concurrent force. So in this one we can see force F1, F2. These are all acting along the single point. So that is called as a concurrent force. So we can mention it as F1 vector plus F2 vector. Next one is concurrent forces. So in this two forces acting at the different points. So in case of concurrent force, both the forces are acting at a single point. In case of non-concurrent, it acts along the different points in the rigid body. Next one, we can see the basic definitions of motions. So motion occurs when an object changes its position related to a reference point. So motion is always relative. So reference point means we can see the starting point and we can see the movement of an object. For example, we can see the example as car. So car starting point is from our home, and it is called as a reference point, and we can see the motion, so it changes its position related to our starting point. Second one is about distance and displacement. So distance is how far an object has moved. So it is basically a scalar quantity. And displacement, so distance and direction from a starting point. So this one is mentioned as vector quantity. So we can see the most basic difference between distance and displacement as distance is the scalar quantity and displacement is the vector quantity. Next one is about speed versus velocity. So the speed, so speed is the distance of an object travels per unit of time. So basically speed is the scalar quantity, and it is also defined as a change in distance over time. So a rate means any change over time. So the formula for speed is distance travelled by time taken. So distance is mentioned as x and time is mentioned as t. So we can mention it as meters per second. So this one is called speed. Next one is velocity. So it is used to signify both magnitude of the how fast an object is moving and direction in which it is moving. So magnitude means we can see the value, and direction means in which direction the object moves. So the velocity is vector quantity. So basically we can see the difference. Speed is the scalar quantity and the velocity is vector quantity. Next one is acceleration. So when an object changes speed or direction, it is called as acceleration. So change in speed or direction. So acceleration tells us how fast the velocity changes. So how fast the velocity changes from time period. So basically the unit for acceleration is meters per second square. So the rate of change of velocity is called as the acceleration. So whereas velocity tells us how fast the position changes. So these are the about definition of the acceleration. So some of the basic principles that we are going to study in engineering mechanics are first one is the parallelogram law, and also we will learn about triangle law of forces and polygon law of forces. So these are all the basic things. And second one is the principle of transmissibility of forces. So in this we will see about the line of action along which the forces acts, and other three topics we will see about Newton's law of motion, Newton's first law, second law, third law, and the last one is Newton's law of gravitation. So first one is about parallelogram law. So according to this law, if two forces acting simultaneously on a body, so we can see in the diagram, so there is a rigid body in the first diagram, and there are two forces such as F1 and F2. So the unit for F1 is 4 units and F2 is 3 units. So represented in magnitude and direction by the two adjacent sides of parallelogram. We are considering this one as a parallelogram and we are taking it as two adjacent sides. The resultant is represented in magnitude and direction by the diagonal of the parallelogram. So normally we can extend the forces diagram from horizontal side, it is a opposite sides are same in parallelogram. So when we are connecting the 2 points such as point A and D, so we can mention it as the diagonal of the parallelogram. So that diagonal is the resultant force, and which passes through the point of intersection of two sides representing the forces, and then we can mention it as the resultant force, and the direction is mentioned as alpha. So this one is called as the parallelogram law of forces. Next one is the triangle law of forces. So triangle law of forces, we can see the definition as, if two forces acting on a body are represented one after another by the sides of the triangle. So one after another by the sides of the triangle. We can see that second diagram. So F1, F2 are the two sides of the triangle. The resultant is the represented by the closing side of the triangle taken from the first point to the last point. We can see the points A and C. So the closing side of the triangle. So this one is mentioned as R1. So this is the resultant force of the two forces F1 and F2. So the third side of the triangle is taken as the resultant force. So in previous case we have taken the diagonal of the parallelogram as the resultant force, and the angle is taken as the resultant direction. So in this case we are taking the third side of the triangle, that one is the closing side of the triangle, as the resultant force, and the angle is mentioned as alpha. So that one is the direction of the resultant force. Next one is the law of transmissibility. So according to this law, the state of rest or motion of the rigid body is unaltered. So unaltered means there is no changes in the value of forces. If a force acting on the body is replaced by another force of the same magnitude and direction. So when you are replacing the force by same magnitude means equal to the same value. If the force value is taken as 10 Newton means you are taking another force of 10 Newton of the same magnitude and direction, but acting anywhere on the body along the line of action. So a line of action means the same lines, we are mentioning it as dotted lines. So the force F acts anywhere on the line of action as the same magnitude and direction. So this one is called as the law of transmissibility, replaced by the force. So the conditions of equilibrium or motion are not affected by the transmitting a force along its line of action. So we can see the first diagram and also the second diagram. The force acts somewhere along the rigid body, and its line of action is extended, and we are taking the second diagram, it is acting on the another one point on the same line of action. So there is no changes in the force acting at different points on the same line of action. So they are mentioning that F and F dash are equivalent forces. So let's see about the Newton's law of motion, first law, second law, third law, and also about Newton's law of gravitation in the next video. So thank you.